let's do an Intel 9th generation CPU in a Z170 motherboard setup and overclocking guide. So right then, it's been 6 months roughly now since I uploaded my original how to run a Coffee Lake CPU in a Z170 or Z270 based motherboard, and since then I have received numerous comments and questions about the mod. Has there been any downsides using the system in a daily use, or are there any missing features or anything similar on the motherboard? And I can tell you right off the bat that a combination of an 8700K plus this specific motherboard here has been working really nicely. I've been using it for gaming, video editing, any type of day-to-day stuff, and all my videos in my channel so far have been edited and uploaded using the rig you see here. And during this year's Computex, this motherboard managed to break many overclocking records with a very highly selected 8700K. So it really shows that the combination is really solid and reliable. Since the release of my original video, more and more unofficial BIOSes and software from other motherboard manufacturers have been released to other motherboard models to support the Coffee Lake CPUs, but the results do vary a lot. For example, Asus released a Coffee Lake BIOS to their Maximus 9 series, but at least currently the hyperthreading feature does not function at all on the i7 and i9 CPUs, which is a huge downside considering that hyperthreading is the main feature we pay for on those expensive CPU parts. So I wouldn't really recommend you stick to a motherboard like that with such an expensive CPU. But in the end, this is more about what can be done rather than what you should do, because in the end this is just a huge budget way to give more life to your old Z170 or Z270 based motherboard. Since Intel's 9th generation CPU launch, I have also received questions that do the new CPUs, especially the 8-core 9900K, work in this motherboard as well as on any other Z170 based motherboard, and I can tell you right off the bat that they do work the same way as the 8700K does. But also we are starting to see some negative side effects of this budget method now. For example, the lack of VCC pins can be seen that we can't reach as good daily clock speeds compared to a new Z390 motherboard. And also the VRM temperatures are really high on some of these old motherboard models, and you have to keep an eye on it if you decide to try the power-hungry 8-core in a motherboard like this. Also, I was told that I should be covering those two particular contact pads on the bottom side of the CPU on top of shorting out the two, as in otherwise those two particular contact pins in the CPU socket might burn out in time and cause some weird negative side effects or even make the motherboard unusable. But in my case, as I've been using this system daily for half a year now, I haven't seen any weird behavior or any parts missing, so I'm pretty confident that covering those two isn't absolutely needed, but it's for sure something wise to do if you want to do it. And also, since the jumper wire location is so easy on these Asrock OC Formula series, I realized that you don't even have to cover the two, you don't have to short out the two particular contact pads on the bottom side of the CPU in order to get the system to start, which is a really nice thing, considering that shorting the two contact pads with silver paint, pencil or anything like that is for sure the riskiest and most uncomfortable part of the whole process. So with this motherboard you pretty much only need a BIOS in either of the two BIOS chips that supports these new 9th generation CPUs. I always recommend you have an old BIOS as a backup in the second BIOS chip, so you can still use old CPUs like 7700K or the i3 variants if you ever have to use them. And then just the modification point here shorted to ground with a jumper wire. So other than that, you just put the CPU like that without anything on the back side into the socket, clamp it down, and then the system is pretty much good to go. As you can see, I'm now in the BIOS running the 9900K CPU with the BIOS version L7.51F, which is the first BIOS for this motherboard. Supports the new 8-core CPUs. So the overclocking of this CPU is very straightforward, same as you would if you were clocking an 8700K, 7700K, or even the very old Skylake 6700K. They all run the same and are overclocked exactly the same way. But just a word of caution, and this is just overall about these CPUs, as they are soldered, but the soldering process is not so good as we saw in the BIOS video. You should start at a very low voltage. I would recommend 1.25 or less, but in my case we are running a very strong custom water cooling solution, so we can start at around 1.28, but even at this voltage the temperatures get up really high. When you start overclocking, and this is mainly just for, well, I'm using this motherboard as an example, but the process is very identical no matter which brand motherboard you use. But you start in the CPU settings, you go from CPU ratio and select all cores. That is just my recommendation. I generally just test, or at least I initially test by stressing all cores at the same time. All of these new CPUs like 900K can do, well, they pretty much all do 5 GHz if you have a strong cooling, but some will require quite high voltage, but well, not all will do 5 GHz with AVX stability, but they can, most of them can do or at least cinebench. And now we are just quickly testing cinebench, which is a good indication of simple CPU stability. So I'm starting at around 53, as I already know my CPU, but you should start at 4.8. You don't have to start any lower than that. Just put 4.8 and work your way up from there. Cache is not so important as with previous CPUs, so I just set it to some value, but significantly lower than core anyways. So I'm just setting 48 here. But at the bottom of the CPU settings there are very important settings you need to change. These are the power limitation settings. I just recommend max them out and forget them, pretty much. If you don't touch them, especially these two here, your CPU will most likely throttle under heavy multi-threading conditions. So just put in max values. These are generally the same on every motherboard models. So 4095 watts on long and short duration power limits, and 255.5 amps as max current limit on both memory controller and CPU core. Also, what is important is the AVX ratio offset. This setting allows you to run a lowered CPU core speed for any program that can utilize the AVX instruction sets. Generally, AVX based loads have a much higher power consumption than any standard CPU load, and therefore both the CPU core temperatures as well as the motherboard VRM temperatures go much higher in AVX based loads. And this setting was introduced when the CPUs came out with the new AVX2 and the newest AVX512 instruction sets, which have even higher power consumption than the original AVX1. And this setting is really helpful, as if you find a stable overclock, let's say of 5.2 GHz for non-AVX environments, you can use this setting to lower the CPU clock speed to, let's say, 4.9 or just 5 GHz for any programs that utilize the AVX instruction set. So with this you can guarantee that your CPU will always be stable in different types of loads that it can possibly encounter. So I would recommend you use a setting of 1 to 3 in this, so 100 to 300 MHz lower than the CPU core speed in standard programs, especially with the 8-core, as these have even much higher power consumption in general than the 4 or 6-core CPUs. So generally I tend to use a setting of 2 here. In DRAM, this is of course very dependent on your memory kit, and we will get to that just later, but you can generally just start with your XMP profile. That's pretty much good enough. And in voltage, again, I recommended that you try 1.25 or below and see where your temperatures raise, because these CPUs run really hot. I'm just putting in 1.28, as I already know my CPU quite roughly. Load line calibration, I recommend you find a value at which the CPU core voltage is pretty much the same at load as well as in idle. Some of the load line calibrations, especially on Asus and even on EVGA, the highest settings tend to overshoot a bit. Like if you're, let's say you put in 1.3 volts as your set value, the highest load line calibration settings will overshoot your voltage to, let's say, 1.34, even beyond. So on Asrock this is very easy. On the right side you can see level 1 is the one I suggest. I've measured it many times over the years with multimeter, and the real value under load is very close to the set one. So if, as I'm setting 1.28 here, the real value under load is around 1.274, so it's very close to the set value. V-core PWM switching frequency, this is something you need to test yourself. It has very minimal impact on your V-core requirements per given clock speed, and this will increase your VRM temperatures quite, or it can increase them quite heavily. So I would just recommend you keep it at the lowest value for starters, and when you have found your limits you can try to fine-tune with this, so you can test the max value if it has any impact. But other than that, it's not a very big thing, but it's good that it's there, and I tend to keep it at the max setting, which is 1 MHz. DRAM voltage, just set as I recommended that you start with your XMP value. So well, anything up to 1.5 volts is very safe for daily use, as there are already DDR4 kits out there which have 1.5 volts as their rated voltage, and the manufacturers offer them lifetime warranty. So I can pretty safely say that 1.5 volts is safe for daily use. VCCIO and VCCSA, I recommend you type in these manually, because sometimes on auto they can go very high when they are left on auto. So if you try very high DRAM speeds, the BIOS might put in even 1.4 volts on both these two. So 1.25 is the maximum I would use for daily use, and I would recommend that you just start, or just use 1.15 on both these two and it should be enough for, I mean, even for very high DDR4 speeds. When you have set these clocks and voltages for both CPU and memory, there's nothing really else we have to do here, just unless you want to disable some motherboard features, but it's quite rare that you would. I would just recommend you save a profile and we go to the OS and see, test the stability and how well this CPU overclocks on this very rare and antique Z170 motherboard. So as you can see, we are only running 1.28 volts on the V-core, and the core temperatures are already ramping at around 70 degrees, which is really high considering that the CPU is both soldered and under very strong custom water cooling. So the 1.25 is absolutely maximum. I would recommend you start if you are just running a very simple air cooler. But from here, the procedures for testing your overclocks is pretty much the same. I tend to just test the maximum. I test the speeds at around what voltage is required per given clock speed. So if 1.28 was fine for 5.3, I just test if 5.4 is still stable at the same voltage. So I use Asrock's formula drive software to just change settings in the OS. In CPU-Z we can see the clock speed is now 5.4, and let's test if it's still stable. It seems to run pretty fine. As always, as I told in my previous video, cinebench is not anywhere near enough to guarantee your daily stability. You would have to run some few hours of Prime 95. Even the non-AVX versions are fine, but cinebench is just very simple. It's a very simple way to test your CPU stability. So 5.4 was still stable, which is pretty insane number considering that this is an 8-core CPU on an unofficial Skylake chipset motherboard. Pretty much one of, maybe if not one of the best CPUs in the world in this category. So let's test 5.5. This will surely crash. I'm absolutely sure. Yeah, the CPU didn't even, I mean the test didn't even start. So from here we just restart the system and try to go even further by increasing the voltage. So to test your daily stability, I would do the same way as I recommended before in my earlier video, that you use Prime 95. You have to decide which version you want to use. 26.6 is the minimum I would recommend. It is the last version of Prime that doesn't support any AVX at all. Just a huge word of caution here. If your cinebench temperatures are already above 70 degrees, let's say just as I had in my run, if you run the newest version of Prime, which supports all the AVX versions out there, your CPU will hit 95 to over 100 degrees instantly, so be very careful here. That's why I tend to recommend use the non-AVX version first, or maybe 27.7, which uses only the AVX1. So with those, the increase over cinebench in temperatures is not so radical compared to the newest versions of Prime. So now I will be testing if I can run 5.4 GHz with the original set voltage of 1.28. Let's see if I can run the test at all. So we just open Prime 95, and I'm using core temp to monitor the core temperatures. As on this board I cannot monitor the VRM temperatures at all with software. I have to just monitor it myself with my own thermometer. So we just open Prime 95. I recommend small FFT as before, as this puts maximum stress on the CPU, and just press run. As we can see, the voltage is only 1.28 and the CPU temperature is already going above 75 degrees. And remember, this version is not using AVX at all, so please be very careful when you start using Prime 95 in general, because the latest versions will hit to 100 degrees or even above. So, and where at that point the CPU will throttle, and running so high temperatures is not very healthy for long use. And as we can see, we crashed, so we just have to go back and either lower the clock speed or go higher in the voltage. As the previous attempt crashed as well, I saw it's a good idea to come down in clock speed from 5.4 to 5.3 and set the voltage back to 1.28, as it seems that the temperatures are limiting the stability more than the voltage. So it's better to just find a good sweet spot where the temperatures aren't rocketing that high, as now the hardest core is around 80 degrees, which is already quite high value. From here on, I would recommend to just run this test for at least 1 hour, but keep an eye on the VRM temperatures while you run it. It's absolutely recommended that you have some active airflow over the socket area now with these 8-core CPUs, as my guess is that the CPU is now pulling around 200 watts, which is quite high value for a mainstream socket. So the system has been running Prime 95 26.6 for 1 hour now, roughly, and the core temperatures are still at around high 70s to mid 80s, so it's pretty high considering this doesn't have any AVX load, and the VCore is just at around 1.28. And I can already feel that the VRM heatsink is really hot by touching, and as I said before, you should really watch out for VRM temperatures, because these 8-core CPUs can really draw a lot of power, much more than these motherboards were originally designed for. So let's see how warm the VRM is using an infrared thermometer. It's pretty hard to measure, but let's test. So it's 70, 84, 85 degrees. Yeah, if it's measured 85 degrees, so it's the real MOSFET temperature can be over 90 degrees, so it's insanely hot, considering that I'm having some very active airflow over the socket area. So if I didn't have any, yeah, the VRM temperature would easily go over 100 degrees very quickly. So if you decide to use an 8-core CPU on an old motherboard like this, please have some strong airflow around the socket area, because yeah, we could almost say that finally this legendary motherboard has met a CPU that can put it to its knees. So when it comes to the memory overclocking, I would just recommend you approach the same way as I guided you in my earlier video. The aim is to find good balance between latency and raw frequency. So it's you should take your XMP values and just try to improve them. So I usually try to aim for around 4100 to 4400 in megahertz, but with tighter latency than the XMP values have. So I will be trying to shoot for 4133 with 16, 17 and with tightened subtimings, so this should give a much better performance than the XMP values of this kit, which is which are 4133 MHz, but with 1921 latency. In many of these subtimings can be tightened quite a lot, and on auto they usually go to very loose values, so you can seriously improve your overall daily performance by tightening them down. The key values here are the TRFC. On auto this would be something like over 700, but manually we can tighten this to 360. These few ones here are not so important, but I generally set them. You can just copy the values what I put in here. They should work. For active window and cache write latency are both important. As you can see on auto we got 42 on the other and cache write latency of 19, so these are pretty loose values. If I really pushed it, I could even run a cache write latency of 9 here, so it's less than half of the value what is set on auto. So I would recommend you put in 23 instead of the auto 42 on the for active window, and tighten the cache write latency to maybe 14 is a good value, which should work. TCKA KE is good to set yourself. The lowest you can run here is 4, but you should be able to run 5 or 6 anyways. On auto the value is 7. These few ones here can be left on auto. Even on auto they usually stay at a fairly good value. These 4 ones here, as on auto they usually are set quite loose, but it's quite hard to find a stable value on these. So for starters I would recommend you leave them at auto, and later on you can try pushing them down. The lowest value you can run on 4 of these is 12, but that's quite hard to run, and usually it requires very high memory voltage. These two here, you can read them if you just pause the video, but they are tied to the 2 other values in secondary timings. You can usually just leave them at auto as well. These last values here, you can usually run them by setting 4, 4, 6 or 7, and then the bottom 3 as 4 as well. I just will set them as 4, 4, 7, 4, 4, 4. Here we can leave the memory section and go to the voltage. As I said at the start of the video, anything up to 1.5 is very safe for daily use. Usually over 1.6 is not necessary or very wise, because it doesn't scale that much anymore, and it will not give you much stability gains. So I would recommend you find your best configuration at around 1.45 to 1.5 voltage, and leave it that way. VCC-IO, VCC-SA, use at least 1.15 if you are trying to find really high memory configuration, but as I said earlier, you should not use over 1.25 on both of these for daily use. From here, once we have set all the values and the memory, we will just see if it's stable for posting and go to operating system and see if it's stable. So once we are in the OS, we can use Asrock timing configurator to see if all the values we set are setting correctly, and as we can see they all are. Here I would recommend you, for stability testing, you use either Hyper-Pi benchmark, which I used in my earlier video, or the memory test program, which is, the operating system version, not the DOS version. This is the free version which you can download online. I will have the link in the description below, as it's not the purchased one. The maximum memory it can test per process is around 2 GB, so we have to open many of these at the same time to test the full capacity of our memory, as we are running 2 8 GB sticks, so we want to test close to 16 GB in total. We can see the memory use in Task Manager. On idle it's only 0.5 GB from total 16, so in the memory test program we'll just type in 2000 and start testing. You can see it has started testing and the percentage is going up, and we will see if there are any errors. They will show up, and in the Task Manager we now see that almost 2.5 GB of the total memory is being used. So we just have to open many of these and 2 GB in each one. I find this method is much better than Hyper-V, and generally, I mean, in my testings the instability shows up much faster than running Hyper-V 32M. So generally, if you can pass this at full capacity, it should be stable for daily use. So as you can see, we already found one error. So from here on we will just go back to the BIOS, loosen things up or increase the voltage. So I will get back to you in a second. As the previous attempt crashed at around half of the memory capacity relatively quickly, I went back to the BIOS and loosened up the main timings from 16, 17, 17 to 17, 18, 18, 32 with command rate 2. Many people ask me if it's wise to shoot for command rate 1 with much looser settings. It varies. Some programs like command rate 1, but at the same time some prefer much higher frequency with tight main timings with just command rate 2, so you have to test yourself. From here on we will just do the same thing, open many memory tests running at the same time and see if we can pass full capacity run without any errors. Alright, since we could pass both Hyper-V 32M on each of the CPU cores as well as memtest, we could now go back into the BIOS and see if we could push the memories even a bit further. Sadly, on this motherboard I can't use any higher memory multiplier than 4133. So if I wanted to push any higher memory frequency, I would have to use base clock pretty much. But base clock has some downsides as it affects the CPU as well, and it's not so easy to use compared to just multipliers. So the easiest way from here would be just trying to tighten down the memory latencies even a bit more. Last time the 16, 17, 17 main timings crashed pretty fast in memtest, so I could try that again, or just 16, 18, 18 with a higher memory voltage of, let's say, 1.5 instead of 1.45, and see if it could remain stable. Or I could just use these main timings and try to tighten down the sub timings even a bit more, but I can say that this profile already is pretty fast and it beats the standard XMP profile hands down in any sorts of use. So I could just use this in my daily configuration and see how well it performs in games and other sorts of day-to-day stuff. Alright then, as we could see, the old and legendary Z170M OC formula from Asrock can still handle these new Intel 9th generation CPUs, even the 8-core 9900K just fine. At the start of the video I was really skeptical how well this old motherboard could run these new 8-core CPUs, as the old Skylake based socket is not designed at all for these new power-hungry 8-core CPUs, and how high the V-core requirements would be per given clock speed compared to the new Z370 or Z390 boards. But I was really surprised how well this motherboard can handle this specific 9900K. I could even beat the results I got with the new and unreleased EVGA Z390 Dark. around 30 to 40 millivolts for 5.5 GHz Cinebench R15, which is absolutely freaking amazing. 5.5 GHz with an 8-core CPU with just ambient based cooling with so low voltage as low as under 1.3 is just absolutely freaking amazing. Of course, this is a budget option, and we are already seeing some negative side effects of it. I've talked with other more advanced users from the community, and they are seeing that the old socket cannot reach as high core speed for multi-core scenarios under LN2, but the difference is very small, only like 5 to 20 MHz compared to a Z390 board. Also, we now saw that the VRM temperatures are becoming a huge issue even with this motherboard compared to what the temps were with an 8700K in my earlier video from the last summer. If you don't have any airflow, the VRM can easily hit 90 or even 100 degrees. But if you have very strong directed airflow around the socket and towards the VRM heatsink, then this combination should still be viable. Also, one bad side effect was that this board doesn't have as many memory multipliers compared to the more new boards. So as the maximum multiplier is 4133, so we cannot really go much higher in the raw memory frequency without using the base clock. Of course, you can go higher with base clock, but using that is not so comfortable compared to using multipliers, but the option is still there if you want to use it. Also, it's still sad to see that Asrock cannot post very tight RTL or round trip latency options at very tight memory settings, but that's been an issue with Asrock boards for a few years now, so it's something I already expected. But other than that, there is not a single feature on this motherboard that is not working with an unofficial CPU like this. All the USB ports, the M.2 and all the SATA ports function as they should, so it's pretty much running a 6700K with just 8 cores. The next thing I will be trying is putting this particular CPU on LN2, as it seems so promising. I'm hoping this will be the first ever CPU that can do 6.95 or even 7 GHz for Cinebench R15. It will be really interesting to see. If you like to see more content like this, and if you like this video, please like and share it again, and subscribe to my channel. I will see if I can make more content like this in the coming weeks. See you soon, and bye.